All right, we got a mixed Anova here. She's got repeated measures. She's got 3 beers measurements, 3 wine, 3 water measurements, and 1 categorical variable, gender. So the first thing we're going to do is look for normality between the beers and the wines and the waters. So we're going to go to Analyze, Descriptives, Explore. You should be pretty good at by now. Get in there, you ratbag. And so everything that's not a categorical variable. And we want the descriptives, and we want the histograms and the normality test. Click OK. First box, so it tells you how many are in each of the DVs, right? How many beer and sexies, how many beer and corpses, 20 all the way down. That's good. Descriptives of each group. So you got a 21. You got a 4. Oh, yeah, there's going to be significant differences all over the place here. But here's our normality check. So according to this, the beer plus corpse violated the assumption of normality, and that's the only one. So if 1 out of 8 violated, that's not a big deal. Just mention that one of them was violated, but the other 7 did not. Second, independence of observation. Again, we're just going to assume it. Number 3, homogeneity variance. This is kind of important. Sphericity is not an assumption in a mixed ANOVA. If you have a between group variable, sphericity is not in play, okay? But we do have to look at the homogeneity variance, just like the regular ANOVA. So we're going to go ahead and run our ANOVA. So let's run our mixed ANOVA. We're going to analyze general linear model. We're going to do repeated measures here, right? And there were 9, right? 3 wine, 3 beer, 3 water. And we're going to define those 3. Those are going to be our repeated measures. And our between groups is our gender, right? All right, just a heads up, my computer keeps crashing, so this video might not get finished. We're going to click OK. All right, so we're looking for the homogeneity variance. There's 2 ways to do that on a mixed ANOVA. One is through your box's M test, and according to this, you did not violate the assumption of homogeneity variance. And the other one is the Levine's test. So remember, we don't care about sphericity, so don't look at the Mauchly's test. But there should be a, where are you? There it is. Levine's test of homogeneity variance. And again, did not violate. So that's good for the assumptions. Okay, so let's go ahead and, we just ran the test, so let's go ahead and interpret the test. So keep in mind, you're looking to see if there's a difference between the 9 different levels, right? The beer, sexy, beer, corpse, beer, person, which we already know there's a significant difference in there. And we need to see if there's a significant difference between the scores between the males and the females. And lastly, any kind of interaction between one of the 9 different water levels and wine levels and one of the genders. Okay, so that's what we call interaction. We're going to look at that. So first of all, we're going to look at between subjects. And according to this, there was a significant difference between the male and the female scores in regards to all of the water, wine, and beer grouped as a whole. So I'll say that again. There is a significant difference between the males and the females in an overall scoring thing. Now I'm going to scroll back up to find the test within the subjects, right? That's the big one right up here. There's bam. So this is the contrast. We don't want contrast. Don't be careful. The boxes kind of look the same, but they're not the same. This is what we want. Test of within subjects. So this is going to tell us if there was a significant difference between the beers and the wines and the waters. And yes, there was a significant difference between these guys. Okay. And this will tell us if there was an interaction between at least one of the different levels of the beer or the wine or the water and gender. That's what this little star means. And there was a significant interaction. So that means you got to look it up and find out which one has the difference, right? There's a difference between males and females in their scoring depending on whether they drank water, beer, or the wine. All right, so here's your main effect. So the main effect for between group, to see if there's a significant between the genders, you would go to your between group box, look at the partial at a squared. Okay, so that is your effect size for gender. Okay, your effect size between your repeated measures is the partial Lettuce squared here. So there's that one. And then there's an effect size for your interaction because it's significant. Okay, and there's that one. So that's how these came about. So I'm going to go ahead and write up the results real quick. Hold on. Starting with within subjects. So that's the difference between the 9 repeated measures. According to this, there was a huge significant difference somewhere between the 3 beers, 3 wines, 3 waters. Okay, that's what this means. And then we kind of look at the between subject. I think that's at the bottom down here. So according to this, between males and females, again, there was a significant difference in their liking scores. Huge difference. And then for the interaction, you go back up to the test within group again. You look for this little star here, right? Factor 1, that's your repeated measures. And it's going to looking for interaction between gender. And there was, again, a significant interaction. I'm sorry, this is the wrong box. I do this all the time. You need this box, test of within subjects. But again, you look at factor 1, asterisk gender, and again, there was a significant interaction. So in other words, either the males or the females are scoring much higher on one of the 9 repeated measures or much lower on one of the repeated measures than the rest of the group as a whole. So you would have to look up that individually, but that's, you don't need to look that up. So, but let's write up this bad boy, see what it looks like. Okay, here's the write up. So a mixed ANOVA, 1 repeated measure. So the DV scores were negative 100, means they hated it, to positive 100, which means they loved it. Between the 9 different repeated measures, and the between groups were the genders. Based on that, there was a significant overall difference in between males and females. Right, that's from the between group ANOVA. There was a significant difference between the 9 repeated measures. That was the test within group ANOVA. And then the last one, there was a significant interaction. So that's it. I'm sorry this is such a mess, but I got to go. MGZ out.